Again, it's always best to work examples to see if we truly understand what we're doing. So we're going to return to the decomposition of magnesium carbonate, which goes to magnesium oxide and carbon dioxide. Previously we showed that delta S naught universal was negative 162.7 joules per Kelvin. So the challenge now, what is the sign of delta G naught, and can we arrive at the same value of delta S naught universal by using standard Gibbs free energies of formation? So here we have our little table for the Gibbs free energies of formation. Let's go to the next slide. Okay, for the Gibbs free energy, we have our equation here, which is very similar to what we did for enthalpy and entropy. And we start with the products, and we put them in here. Products. We have two products, and then we have one reactant, and we just put those numbers in from the table on the previous page, and we find that our change in Gibbs free energy is plus 48.3 kilojoules. So once again, this time using the Gibbs free energy, we've shown that the reaction is not spontaneous. And we're just expressing as kilojoules there because we're not specifying a particular reactant or product. So we want to check that and make sure that we come up with the same value of delta S naught universal. So here's our two things for Gibbs free energy. We calculated that the Gibbs free energy change for the system is 48.3 kilojoules. It was defined as negative T times delta S naught universe. And what are we doing here now? Now it's just a question of putting in the numbers, rearranging them, dividing, and guess what we find? Delta S naught universe is minus 162 joules Kelvin. The same thing we got with the entropy process. That's nice. It's good that it all works together. Let's try another example. We're going to have the combustion of ethene, and you know it's combustion because it's reacting with oxygen. Is it product driven at 25 degrees Celsius? Here's our table of Gibbs free energies, and we will need them on the next page, which is where we're going to go now. Here's our reaction, and let's look at the stoichiometric coefficients. Have a 1 there, a 3 there, a 2 there, and a 2 here. So we're going to sum up the products first and then the reactants. So right here you see the 2, that's water. Here's carbon dioxide. Right here is going to be ethene. And over here, who's the 0? The 0 is oxygen, right? It's a pure element, so that has a 0 free energy. We do the multiplication, we add everything together, and you get a change in Gibbs free energy at negative 1331.3 kilojoules. That means, since it's negative, that it is product driven at 25 degrees Celsius.